Sometimes chemistry is not really as complicated as the so-called experts say. A somewhat complex formula for a wall primer at a paint company had a simple problem. This primer was one of the hottest sales items for the manufacturer. Unfortunately, the product failed in batch production on a regular basis. The manufacturer had hundreds of drums of waste paint from batches that had failed during manufacture, littering their warehouses and parking lots. 300-gallon raw material tanks were filled to the brim with product that would one day be sent down the waste recycling process line without ever having a chance to prime a wall. The manufacturer could not stop production because the demand for the product also carried with it the demand for other product lines of more costly and higher-priced paints. If the manufacturer stopped one, he might indeed stop the other, and maybe even stop his business. The end result was that the manufacturer was running out of room for the failed batches, but had to continue to manufacture the item knowing that every third batch would end up in his parking lot. This LIMS administrator was at that time simply a chemist, but I knew how to use the tools that LIMS systems are built with. I had been trained in the use of design of experimentation and understood statistical process control. Without a LIMS system, I had the understanding to check the data concerning the batches, and even went as far as to check the dates of the failed batches and the weather conditions at the times of the manufacture of those failed batches. This is what the LIMS system does as well, but would have done it on its own and automatically. One day I asked if I could work on a problem that had been pored over by chemists in the company for over 2 years, and was told that I could take a look, but I was wasting my time. I walked through with the batch knowing what I was looking for: excessive temperatures during processing. I had some insight into the use of slurried titanium dioxide from my work in the lab, and thought that it seemed strange that the batches began failing the spring after the formula change to slurry use. The batches also seemed to fail less frequently during the winter months, and almost every batch failed in the summer. I knew that I was looking for a temperature problem. Paint is manufactured by creating a grind of pigments and then adding a latex base to the grind before canning the products. This, of course, is a highly simplified look into this process, but for our purposes these are important aspects of interest. I observed the grind and noticed from previous formulations that the water normally added to the latex had to be reduced because the slurry added water to the system. As I said, I have had some experience with slurries in the lab, and I understood that these materials were designed to achieve optimum grind paste, leading to high temperatures through friction of pigment on pigment in pre-cavitation environments. As I expected, the grind reached temperatures over 100 degrees Celsius, and steam was boiling out of the grind paste before the letdown of the latex. Cheap latex polymers are not thermally shock resistant. As I watched the slow addition of the polymer blend, I ran to the mixer and stopped him from finishing off the batch. Sure enough, the polymer surface coating made up of surfactants had broke down and the polymer was reacting in situ, resulting in the identifying kickout that had characterized all the previous failed batches. Unfortunately, there had been too much latex added to fix this batch without filtration, and the repair took the rest of the afternoon and into the night. But when the grind paste had finally been filtered and the residual latex kickout was hardly noticeable, the batch was completed and sold as off-spec product. At least the product would not be added to the parking lot. I went to the bench and reformulated the batch according to what I had learned, holding as much water and solvent as I could to reduce the temperature of the grind before addition of the latex solution. One last problem came from an aggressive solvent that had to be held out until the very end of the batch and added slowly with agitation, since there was no water left to premix it with. This product no longer caused this company any problems. There were no more barrels in the spaces marked President. The problem was that the formula was changed to reduce cost of manufacture. Slurries reduce cost by saving grind time and reducing additives during manufacture. Unfortunately, no one took into account the sensitive nature of the chemistry involved, or how simply a change of that type could cause problems. The LIMS system would have noticed the changes and problems the winter the first slurry was used. That is why the LIMS system, as well as a superior LIMS administrator, is so important to your company. You too could be caught in a no-win situation that would force you to lose customers and customer confidence through a simple change in formulas that intend to save costs. The LIMS system will prevent those mistakes and help correct past mistakes. This company was lucky to have someone who recognized the problem and was able to apply statistical analysis on paper. But it would have been so much easier to reach those conclusions with the aid of a program intended for that purpose. I still remember that night when I had to squeeze filter bags of grind 5 gallons at a time by hand until the entire 650-gallon batch was cleared of all latex kickout. The LIMS would have prevented that. But I did get a pat on the back from the boss.